6.3 goes over addition and subtraction of rational numbers or rational expressions. When we look at these, you want to keep in mind when you're adding and subtracting fractions, your denominators must be the same in order for you to add or subtract your numerators. So make sure the denominator is the same, keep the denominator, combine your like terms in the numerator. If we look at example 1a, we have 3 over 2x plus 5 over 2x. Your denominator from both of these fractions are the same. So keep the denominator and just add the numerators. So 3 plus 5 gives us 8. It stays over the 2x. We can simplify the 8 and the 2 because they are both divisible by 2. So this gives us a 4 over 1x, or just 4 over x. For example B, we have 5x minus 3 over x minus 1 plus 5 minus 7x over x minus 1. Both of these fractions have the same denominator of that x minus 1, so we're going to keep that and combine our like terms on top. So we're going to have 5x minus 3 plus 5 minus 7x. Your 5x and that negative 7x are like terms, so you combine them to get negative 2x. The negative 3 and the positive 5 are like terms. You combine those to get 2. You put this over that x minus 1, and then you simplify. Just like in sections before this, if you can factor, you need to factor. That negative 2x plus 2 has a common factor of negative 2, so we will factor out a negative 2 to give us negative 2 times x minus 1 over x minus 1. Your x minus 1 is on the top and the bottom of that fraction, so they cancel out, and you are just left with the negative 2. For example C, we have x squared plus 4x minus 7 over x squared minus 1 minus x squared minus 2x plus 1 over x squared minus 1. Your two fractions have the same denominators, so we are going to rewrite this as x squared minus 1 in the denominator, and then we are going to rewrite the top as x squared plus 4x plus 7 minus x squared minus 2x plus 1. You see, I put parentheses around both of these expressions because you are subtracting them. That means you need to distribute that negative into the second set of parentheses. So you're going to change the sign on each of those terms in the x squared minus 2x plus 1. From here, you are going to have x squared plus 4x plus 7 minus x squared plus 2x minus 1 all over x squared minus 1. From here, you are going to combine like terms in the numerator. Your x squared minus x squared cancels out. The 4x plus 2x gives us 6x, and 7 minus 1 is a positive 6. So that's 6x plus 6 over x squared minus 1. From here, if we can factor, we need to factor. The numerator, they both have a 6, so we'll factor out a 6 to give us 6 times x plus 1. In the denominator, you have a difference of squares, so that factors out to be x minus 1 times x plus 1. That x plus 1 is in the numerator and the denominator, so they cancel out, and we just have 6 over x minus 1. From here, we are going to look at least common denominators. In order for you to add and subtract fractions, you need the least common denominator out of all of those fractions, and you need the denominators to be the same. By finding the least common multiple out of those denominators, that gives you the same denominator. So with these, if you look at your next example, we are just finding the least common multiple for each group of the polynomials. For example A, you have 4x squared y and 6y. Your factors of 4 are 1 and 4, 2 and 2. Your factors of the 6 are 1 and 6, 2 and 3. Your least common multiple can be taken by not doing this, by finding the factor. Okay, hold on. Let's backtrack here. I'm going to do this a little bit differently, because if I do it that way, you're not going to understand it. All right, so the bigger number out of the two that we have is the 6. I'm going to find the multiples of 6 until one of the multiples is divisible by 4. The first that I have is 6. Then I have 12. 4 doesn't go into 6 evenly, but 4 goes into 12 evenly. Because the 12 works, we'll have the 12. Then we need one of the same of every variable. So even though your x squared is with the 4, but not with the x or with the 6, we're still going to include it. Same thing with the y. We have a y in both, so we will include it. So it's just the 12x squared y that our least common multiple is between the 4x squared y and the 6y. So what I was going to do with what I started with, if you find the prime factorization of the 4 and the prime factorization of the 6, for the 4 you'd have 2 and 2. The 6 you have 2 and 3. You have a 2 in each of these, so you'll bring that down. Then anything else that's left over that doesn't match up, you're going to bring down. So you have a 2 and a 3 also. If you multiply the 2 times 2 times 3, that gives you 12, which is your least common multiple between the two. For example B, we don't have to worry about the actual whole number there because they all don't have one, but we do have to worry about those variables. You need the highest variable power for all of them. You have an A, you have a B, and you have a C for each of these terms. So you're going to include an A, you're going to include a B, and you're going to include C. What's your highest degree on the A? It's 3, so it would be A cubed. What's your highest degree on the B out of all of them? It's cubed, so it's going to stay B cubed. And then what's your highest degree on C for all of them? It's 2. So we multiply these all together, we get A cubed, B cubed, C squared. For example, C, we're given x squared plus 5x plus 6 and x squared plus 6x plus 9. We have to factor both of these. So if you start with the x squared plus 5x plus 6, our factors of 6 that add up to be 5 are 2 and 3. So this is going to be x plus 2 times x plus 3. For the x squared plus 6x plus 9, your two factors of 9 that add up to be 6 are 3 and 3. So that gives us x plus 3 times x plus 3. Look to see if you have the same from each of these. You have an x plus 3 in each of these, so write that down. Then write down anything else that remains. So the x plus 2 and the x plus 3. You do not have to FOIL these out. You can just give the expression x plus 3 times x plus 2 times x plus 3 as your solution. With example 3, we are now adding and subtracting these rational expressions when they do not have the same denominators. So we want to make sure we have the same denominators before we add or subtract. If we look at example 3a, we are given 3 over a squared b plus 5 over ab cubed. You got to first find your least common denominator between these two denominators. So you have that a squared b and you have that ab cubed. You have an a in each. The highest power is the second. So that a squared is going to be part of your least common denominator. Then you have a b in both of these. The highest power with your b terms, you have 1 and 3, is 3. So that's going to be a squared b cubed. That's your least common denominator. From there, what did you do to the a squared b, the denominator of the first fraction, to make it a squared b cubed? You multiplied it by b squared. So do the same thing up top. So that 3 is going to be multiplied by by b squared, so it's going to give you 3b squared. Next you have that ab cubed. How did you get that ab cubed to be a squared b cubed? You multiplied it by a. So you multiply the top by a, and you get 5a. So from here, if you can combine like terms in your numerator, you do so. If not, that's just your answer. So here, we cannot combine like terms in the numerator, so it's just 3b squared plus 5a over a squared b cubed. For example, b, we have x plus 1 over 6 minus 2x minus 3 over 4. Again, like we said with the sections before this, I want to put parentheses around the numerator of that second fraction because my sign between the two fractions is subtraction. From there, I got to find my least common denominator between the 6 and the 4. 4 does not go into 6. The second multiple of 6 is 12. 4 goes into 12. 6 goes into 12. So my least common denominator here is going to be 12. What do I do to the 6 to make it a 12? I multiply it by 2. So I'm going to multiply the top of that fraction by 2. What do I do with the 4 to make it a 12? I multiply it by 3. So I'm going to multiply the top of that fraction by 3. So in the numerator, I'm going to have 2 times x plus 1. I'm going to keep that negative. I'm going to multiply 3 by that second fraction's numerator, which is going to give me 3 times, or negative 3 times 2x minus 3. And this is all going to be over my least common denominator, which is 12. We can distribute the 2. We can distribute the negative 3. So this is going to give us 2x plus 2 minus 6x plus 9 all over 12. From there, we're just going to combine like terms. So the 2x and the negative 6x are like terms. The 2 and the 9 are like terms. So this is going to give us negative 4x plus 11 all over 12. You cannot simplify this any further. You can't factor the numerator. You cannot divide each of the terms in the numerator by 12, or the same factor of that goes into 12 as well. So that negative 4x plus 11 all over 12 is your solution here. With example 4, for a, we are given 1 over x squared minus 1 plus 2 over x squared plus x. I'm going to rewrite both of these denominators in factored form before I even find my least common denominator. For that first fraction, I'm going to have 1 over, it's a difference of squares, so that's x minus 1 times x plus 1. For the second fraction, I have 2 over my least common factor, or least common, my greatest common factor between the x squared and the x is x, so I'm going to factor out an x to give me x times x plus 1. So from here, identify your least common denominator. I have an x plus 1. I'm going to write that down. It's in both of those denominators. So I can get rid of those, and then whatever's left over, I'm going to write down also. So I have the x and also the x minus 1. So my least common denominator is x times x plus 1 times x minus 1. When I do this, I'm going to multiply the first fraction's denominator by x in order to get me to the least common denominator. So I'm going to do the same to that numerator. So that's going to give me 1x, or x, over the x times x plus 1 times x minus 1. From there, I have a 2 in my numerator of the second fraction. My second fraction only had the x and the x plus 1, so it was missing the x minus 1. So I'm going to multiply the x minus 1 by 2 in the numerator as well. Putting down my least common denominator, which is x times x plus 1 times x minus 1, I can now distribute that 2 into the x minus 1 and combine like terms if I have any. So this is going to leave us with x plus 2x minus 2 all over x times x plus 1 times x minus 1. From here, that x and that 2x are like terms, so we can combine these to give ourselves 3x minus 2 all over x times x plus 1 times x minus 1. For example B, we have 5 over a minus 2 minus 3 over 2 minus a. I'm going to rewrite the denominator of that second fraction as negative a plus 2, so that way I can factor out a negative 1 and get it to be that a minus 2 that I'm looking for. So this is going to be 5 over a minus 2 minus 3 over negative a plus 2. I want to factor out a negative from that negative a plus 2 to make it a minus 2. So this is going to be 5 over a minus 2 minus 3 over a negative times a minus 2. Our least common denominator here is the negative, or the opposite of a minus 2. What does the first fraction's denominator need to get it to be that negative a minus 2, or negative a times a, the negative times a minus 2 is a negative, so I'm going to multiply the 5 by the negative. So this is going to give us negative 5 minus 3 all over the opposite of a minus 2. From here, that negative 5 minus 3 is negative 8 over the opposite of a minus 2. Those negatives cancel out, so it's just 8 over a minus 2. For example 5a, we are given 2xy over 4x plus x squared over xy. So you want to find your least common denominator first. We need the 4, we need the x, we need the y. So what did we multiply the 4x by to get it to be the 4xy? We multiplied it by y, so we're going to multiply the top by y also. On this second fraction, what did we multiply the xy by in order to make it 4xy? It's just a 4. So we're going to multiply the top by 4 as well. So this is going to give us 2xy squared, or 2xy times y, plus x squared times 4, all over the least common denominator, which is 4xy. We simplify this, and we are left with 2xy squared plus 4x squared all over 4xy. Now, if you can factor, you can factor. You have the numerator, which is 2xy squared plus 4x squared. They both are divisible by 2. They both have an x. So we'll factor out a 2x. This is going to leave us with y squared plus x over 2x times y squared plus x over 4xy. From here, we can simplify the 2 and the 4. The 4 becomes a 2. The 2 becomes a 1. The x also cancels out. So we are left with y squared plus x all over 2y. For example B, we have 8x minus 8 over 4x squared minus 4 minus 9x over 3x squared minus 3x minus 6. I'm going to start this by factoring everything first. So the top of this first fraction, I can factor out an 8, so it's going to be 8 times x minus 1. Underneath, I'm going to factor out the 4 to give me 4 times x squared minus 1. That x squared minus 1 can then become x minus 1 times x plus 1. On the second fraction in the denominator, I'm going to factor out a 3 to give me 3 times x squared minus x minus 2. That can then factor because my factors of 2 that add up to negative 1 are negative 2 and positive 1. So this is going to be x minus 2 times x plus 1 all over 9x. all under 9x. From here, I want to find my least common denominator after I simplify each of these fractions. So on the first fraction, the 8 and the 4 can simplify. The 8 becomes a 2, the 4 becomes a 1. Your x minus 1 is also on the top and the bottom of this fraction, so it just simplifies to be 2 over x plus 1. On the second fraction, you have a 9 and a 3. The 3 becomes a 1, 9 becomes a 3. You then have the x over x minus 2 times x plus 1, which you can't simplify. So that's just going to be 3x over x minus 2 times x plus 1. This makes things a whole lot easier for you because your least common denominator is not going to be as large. For here, your least common denominator is that x plus 1 times x minus 2. So what do you need to do with the first denominator to make it your least common denominator? You multiply it by x minus 2. So you'll do the same with that 2. Did you have to change anything with the second fraction in order to turn your denominator into the least common denominator? No, so you leave it alone. So we're just going to rewrite this as 2 times x minus 2 minus 3x all over x plus 1 times x minus 2. We will distribute the 2 in to give us 2x minus 4 minus 3x over x plus 1 times x minus 2. From here, we're going to combine our like terms in the numerator. So we have 2x minus 3x, which is just negative x minus 4 all over x plus 1 times x minus 2. If you wanted to factor out a negative 1 from the negative x minus 4, you could have done that. However, it's not going to simplify any further than it already is. So you can just leave it the negative x minus 4 over x plus 1 times x minus 2. For the next part of your lesson, we're just finding sums and differences of these. So we're doing the same exact thing, same concept. Find your least common denominator, turn your fractions into be similar fractions with your least common denominator, and combine. So for example A, we have 1/2 plus 1/3. Your least common denominator here is the 6. From there, you multiplied the 2 by 3 to get 6, so you'll do the same to 1. The 3 you multiplied by 2 to get 6, you'll do the same to the 1. So it's going to give us 3 plus 2 all over 6. The 3 plus 2 is 5, so 5 over 6 is our answer. For example B, we have 1 over a minus 1 over x. So your least common denominator between these two is just ax. We multiply the first fraction's denominator by x, so we'll do the same to the numerator. Second fraction, we multiply the denominator by a, we'll do the same to the numerator. So it's going to be x minus a all over ax. For example C, we have a over 5 plus a over 3. Your least common denominator between these two is 15. So we'll multiply the first denominator by 3. Do the same thing with a, that gives us 3a. Second denominator we multiply by 5. Do the same thing with the a, that gives us 5a. So it's 3a plus 5a all over 15. We combine our like terms to give ourselves 8a over 15. For example D, you have x minus 2/3. This x is the same exact thing as saying x over 1 minus 2/3. So from here, your least common denominator is 3. So we multiply the top and the bottom of that first fraction by 3, and we get 3x minus 2 all over 3.